Welcome back. We're going to continue our discussion of the scientific revolution. When we last met, we were talking about Galileo. He's going to get in trouble here in the early 17th century. The Jesuits had established what's called the Holy Office in the Vatican, and they published an index, forbidden literature. In 1616, the Holy Office labeled Copernican theory as quote-unquote foolish and absurd, philosophically false, and formally heretical, unquote. Galileo was admonished not to accept or to advocate Copernicanism, the heliocentric theory over the geocentric. Nevertheless, in 1632, Galileo thought it safe to publish his, and this is the title of the book, The Dialogue Concerning the Two World Systems, Ptolemaic and Copernican. By presenting the respective merits of the old astronomy and the new astronomy in dialogue form, Galileo himself could pretend to be neutral. So he creates two characters here that are going to have a discussion about science and astronomy, one representing his views and the other representing the views of the old way of thinking. He portrayed it's actually kind of amusing. He portrayed the champion of the old science as an ignorant clown, Simplicio, who was beaten in every argument. Now, here's where it gets dicey for Galileo. Pope Urban VIII believed that Galileo was mocking him as Simplicio. Galileo was brought to Rome. He was examined by the inquisitors. He was made to recant his errors, and he was sentenced to house arrest for the rest of his life. His dialogue was put on the index of the Holy Office as a forbidden book. Galileo shared with Kepler the honor of winning acceptance in time for the Copernican theory. And with Newton, Galileo is credited for demonstrating that the heavenly bodies move according to laws that humans can understand. In other words, it's a predictable movement in the heavens. Now, Sir Isaac Newton, 1642 to 1727. Newton's a very odd character, sort of a mad scientist in a way. He is not only a genius, but he's also dabbling in things that seem kind of silly to us today, not so silly then. Newton expended a lot of time and energy on alchemy, that is, trying to use base metals to create gold. He spent a lot of time trying to calculate the dates of biblical events. So here you can see science and religion are not in competition necessarily, at least within the mentality of the scientists themselves. These are all Christians that are making these astronomical observations. Newton turned to physics and astronomy. He and Galileo are the towering figures of the scientific revolution in astronomy, obviously. Newton's supreme achievement was to put Kepler's laws of planetary motion, that is the ellipse, or the elliptical orbit. He coupled that with Galileo's laws of falling bodies, the concept of inertia, and his own concept of gravitation into a single mathematical physical system that has predictable laws that we can make predictable observations of the celestial bodies. In 1687, Newton published his famous book on gravitation and motion and the mathematical principles of natural philosophy, generally known as Principe. This is a ground-shaking advance in the scientific method and epitomizes the scientific revolution. You yourself are familiar with Newton's laws of motion, whether you know it or not. You can hold a pen and drop it. That's gravity. We think about Newton's, I think I talk about Newton's second law of motion quite often in my American history class when we look at the Zapruder film. And we see Kennedy's reaction to that shot to the head, which blasted him to the back and to the left of his limousine. This creates serious doubt about the official version of the crime proposed by the Warren Commission, which says the president was shot from above and behind. Newton's second law of motion says that a body in motion tends to remain in motion unless counteracted by a body of greater velocity. And the Zapruder film tends to show that Kennedy is hit from the front here, as he's blasted backward and to the left. So whether people are aware of the epistemology that they're using, they're familiar with Newton's laws of motion. Let's draw some conclusions here for the scientific revolution. Big, important, the one thing you should remember, that the universe acts according to laws that man may discover and then observe. That the heavens are not perfect. The old Ptolemaic system, with its rotating spheres, this tendency towards perfection as you move away from the earth, this is demonstrated to be false. Of course, the earth is no longer going to be viewed as the center of the universe. The geocentric paradigm replaced now with a heliocentric model, whereby the earth is simply one of many planets, thereby reducing man to simply one of many species. Remember that the scientific revolution runs parallel to the age of discovery. We're discovering new continents, new weather patterns and currents and plants and animals, and just an immense variety of new things that are now going to have to be incorporated, categorized, and explained. The old traditional authorities have no answer for what's being discovered now as the Europeans venture out into the rest of the world. The scientific revolution establishes an alternative truth to the traditional sources of authority. Another way of saying what I've already been talking about. You have the old paradigm, the old way of seeing things through faith, through the church, through superstition, through tradition. And then you have a new way of seeing things, so through the scientific method, through reason and rationality and logic. And then finally, to repeat what I've already said a few times, the scientific revolution represents an epistemological revolution, a new way of knowing the world. We'll stop there. Thank you.